Hi guys. I just wanted to give you a copy of the notes based on the notes that I post. I'm also going to open up the video that that Ms. Ford also has for this material, just to give you as much stuff as you can have on this section. I'm hoping to be back on Tuesday. I'm struggling with my lungs, so I'm not going to be very long with this video. I'm not going to finish 5.4. I'm just going to go through what Dr. Cheek covered today. So Dr. Cheek told me she covered the fundamental principle of counting, which is pretty straightforward. It's just taking the number of ways each thing can be performed, multiplying them all together. So for example, we have this fixed price dinner at a fancy restaurant, provides the following choices. So we have a super salad, that's 2 choices. We have baked chicken, broiled beef patty, baby beef liver, or roast beef au jus. So that's 4 options. We have ice cream, cheesecake, or parfait. That's 3 options. So the number of different meals is going to be 2 times 4 times 3. And I think, let me double check, that's 2 times 4 times 3. That's 24 different meals. And it's just that simple. The only time I've seen it be a little tricky is when it'll say something like paper choices are gloss or non-gloss, and you have to say, oh, that's 2 choices. But other than that, the fundamental principle of counting is very straightforward. Where things get a little tricky is with the factorial and the permutation. So the factorial is the product of the integer and all natural numbers below it. So remember, natural numbers start at 1. So, and the notation is n factorial, like that, with an exclamation point. So if I see 5 factorial, it's 5 times 4 times 3 times 2 times 1. Which would be, I think it's 60, isn't it? 5 times 4 times 3 times 2 times 1. Nope, it's 120. It's been a while since I've done this. Oh yeah, that makes sense. 20 times 6, right, is 120. So on the calculator, the way we do it, I'm not going to switch. I tried to do this before and I forgot to switch back. So let me just tell you the buttons on the calculator. So I'm going to hit 5. I'm going to hit the PRB button. I'm going to scroll to the exclamation point. I'm going to hit equal, and then I'm going to hit equal again. So this is for the 30x2s calculator. So if you have a different calculator, I would have to sit down with you independently and figure that out. Or I can get with Ms. Ford and find out if she has instructions for your calculator. So another way we have of doing counting is the permutation. And the permutation, we count the number of permutations. It's the number of different ways that a group of items can be ordered. So how can we group them together? Okay. So the way we write this is we write it as NPR. And the calculation for that is n factorial over n minus r factorial. So let me show you, I know Dr. Cheek showed you a couple of different ways of calculating this. I want to show you my way. On the test, I'm really more concerned of you showing me your work. If you show it the way I like, that'll make me happy. But if you show me work and show me that you're not just doing it in the calculator, that's what I want to see. So how many ways can a 10-horse race finish first, second, and third? So you'll notice here, because we're saying finish first, second, and third, the order matters. And that's something that'll be important when we get to the next thing, when order doesn't matter. So pay attention to whether order matters or order doesn't matter. So order matters, so it's going to be 10p3. And that's going to be 10 factorial over 10 minus 3 factorial. Gives me 10 factorial over 7 factorial. Now, Dr. Cheek told me that she showed you how you could do the 10 factorial on the calculator divided by the 7 factorial on the calculator. She also told me she showed you the 10, 9, 8, and you could keep going. But the way I do it is I could keep going, or I could just say 7 factorial. And this is 7 factorial. Because we know 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So we don't need to write it out, but we can go ahead and cancel it. So we're left with what Dr. Cheek mentioned, the 10 times 9 times 8. So that's the 10 times 9 times 8. That's 720. Okay, again, I'm not as worried about how you show me, as long as you show me at least what I want to see. Because I want to see this. I want to see this. If you show me, if you show me 10, 3, 6, 2, 8, 8, 0, 0 over 50, 40. And you end up from there to 720. That's fine. Personally, I think this is a bit much because I get lost in the zeros myself. But if that's what works for you, that's fine. Okay, as long as you're showing me the work. There will be a problem on the test where I'm expecting you to show me the work. Okay, now on the calculator, the way we do it on the calculator is we go 10, we hit that PRB button, and the first thing that comes up is NPR. We hit enter, then we hit the 3, and we hit enter, or the equals. And that's going to give me my 720. Again, I'm going to expect a problem on the test where you show me your work, but always know that you can check it with the calculator, which is very handy. Now, the other kind of problems we have with NPR are probability problems. So a certain student council at a certain school has 12 members, 5 are male and 7 are female. 4 members will form an executive committee consisting of a president, vice president, secretary, and treasurer. Notice here how we're listing the positions. So that means order matters. Okay. What is the probability that all 4 members of the executive committee are female? So let's think about how we do probability. So probability of an event, remember, is the number of ways the event occurs over the total number of ways. Okay, so the total number of ways let's see if I can actually write today, is total number of executive committees. Okay, so we have 12 members, and we're making an executive committee of 4. So we're going to have 12 P4. So 12 PRB, probability 4. So that gives me 11880. So that's the total number of possible executive committees. The number of ways the event occurs are the number of ways executive committees let's see again with the spelling, all female. So you'll notice here that we have 7 females, right? So it's going to be 7 P4. So we're limiting from the 12 total, we're limiting it down to the 7. So we have 7 P4, and that's 840. So the probability executive committee all female is going to be that 840 divided by the 11,880. So 840 divided by 11,880 gives me 0.0707. Okay, that's where I'm going to stop because it goes into combination. I know that Dr. Cheek did more examples in class. So I hope you took good notes on what she covered. And like I said, I'm also going to post Miss Ford's video. I'm going to post these written notes so that you can look at those as well. So if you have any questions, let me know. I'm hoping I will be back in class on Tuesday. I will let you know. I'll let you know what's going on as I find out.